Let's do a few examples with this. This is the sort of question where we get asked, what's the distance between 2 points? So if I get told point A is at 2, 3, and point B is at, let's go for 5, 7. Now this one I know what the answer is going to be, that's why I chose these numbers. It's a nice, simple, straightforward one to start with. Now what we need to think about is where are these 2 points on a set of axes. So let's draw a set of axes, and in a moment I'm going to ask you to think what does this have to do with Pythagoras theorem. So let's just plot the point A, which is at 2, 3. So there's 0, 5, 10. And that's my x direction. My y direction, I've got 5, 10. So the second one is at 5, 7. There's 5, 5, 6, 5, 7. And we're being asked to calculate what is the line length between these 2 points. So I'm going to give you a few moments to think about it and think, how can I make Pythagoras appear in this problem? Where is there Pythagoras in this problem? Hopefully a few of you will have remembered we've drawn right angles before when we wanted to find the slope of this line when we did the algebra and equations of lines. When we did the gradient, we did the y direction first and the x direction second. Okay, that created a right angle triangle where the length of the line AB is my hypotenuse. So the length AB, often written as the two lines endpoints with straight bars either side, it means the modulus, the size of AB. And that, if I remember my thinking yesterday was in blue, is my hypotenuse. The other two sides are my A and my B. So what I've got to work out now is how big is A and how big is the side A and how big is the side B. We're going to do it as a little calculation on the side just to remind ourselves what we're doing. So A is actually the difference in the two y values. So my y values are 3 and 7. 7 minus 3 is 4 centimetres or 4 units. B is the x direction, in the way I've chosen to label it, and that is a difference between 2 and 5. Now I'd always encourage you to do the same order. It doesn't really make a difference when you're doing the size of length of the line, but if you get into the habit of doing all the b values minus the a values, or all the a values minus the b values, when we come to doing gradients, you won't trip yourself up, because remember the order is important for gradients. Okay, so that's my thinking so far. I know A is 3 and B is 4. So put those in. And now I can calculate, right, I've got Pythagoras. Think back to the last lesson, h squared equals a squared plus b squared. So all the stuff you see in white and green is what I'd expect to see in a question. The other bits are nice, they're thinking steps to see. So for h, I'm going to put in my length AB squared. It could be a letter, but I'm introducing a little bit of new notation as well. AB squared is equal to A squared, which was 3, plus B squared, which is 4, or 4 squared. Put the numbers in, we got 9 plus 16, which equals 25. I don't need a calculator to do the square root, but remember, I do the square root of both sides, I'm doing the square root of 25, and that is 5. It's actually a standard triangle, it's a 3, 4, 5 triangle. Just for a little tip for you all, I wouldn't really expect to see 9 plus 16 either from most people. I'd expect you all to be able to do that on your own. Now, just in case you don't believe me, let's set that up as a graph. A is at 2, 3, B is at 5, 7, and this length of line, if I show you what the length of line is, this is the length of 5. So you can now see, I can measure it using Geogebra. This is actually Geogebra running, and I've just got a narrow window, which is why all the stuff appears below. So I'm just going to make up a couple of other examples. The beauty with these is you're not often asked to calculate a position. We will do one at the end where give me a position question comes up, and it will show a little bit to do with weird directions. But all we're going to do is make some quick calculations today. So I'm going to do these on one set of axes, draw a set of axes, and we'll check them afterwards that I've got the right distances. I'm just going to give myself a few points on there. So move that over. Come on, where's the selector? There's the selector. Just move it right over to the right hand side, because when we come to measure them, do it properly, we'll put it onto Geogebra. So 0 in the middle, 2, 4, minus 4 in that way, 4 up, goes up to y, goes across in the x, and minus 4. Just being really careful. Some of you need to be very careful with your axes. I remember from doing the algebra, the equation of a line, some of you are not very clear about, you've got 0 in the middle, then 1 square to the side is 1, 1 up, minus 1 to the left, and minus 1 down. The 0 is definitely in the middle, and it's got to be in the middle. That's why I put it over the cross in the centre there. Some of you need to be really careful of that. So let's create some points on here and lines. So I want to do a point here, which is between minus 4, 3, and let's go to minus 2, minus 1, 2. That's my first one. Let's put that in. There's the line. So we're just going to do a quick calculation with it. I need to know how tall is it. Well, this time it's going down. That's minus 1 down, and going across 3. Okay, so up and down first. The only reason I'm doing that, it reinforces what we did with gradients. I will need my calculator, so I'll pull my calculator in, and get out the way, Geogebra. I want my calculator to one side, and all my calculations going on next to it. I drag this across. Let's drag my axes in a bit. I don't need them all the way over there. All of that across to about here. That's all nicely in line. I can now go back and have my calculator in the screen as well. Okay, so we know that I need to label it, or I should label it. Distance we want is the h. I'm going to lay A as across, B is up. So now I'm going to put it into my calculation. So h squared, I haven't got a label for it, so I'm going to call it h squared, is my a squared, 3 squared, plus, and this is the bit reason I chose one of these, if you've got a minus, you can ignore it, or when you come to put it into a calculator, make sure you put it in brackets. If you don't put it in brackets, a calculator often makes a mistake. It doesn't matter which of the minuses you use, you've got a minus there and a minus there. Most calculators will not square a negative number properly. So if I put in, just show you -1 squared, well, we know -1 squared means negative times a negative, which should give me a positive answer. But all calculators that I've come across will give you a negative answer. It's a mistake in the calculation. That's why when you see me put substitute in, I always put brackets on them. is so that when I'm substituting values in, if it's got a negative as the value going in, it reminds me when I put it into the calculator to put a bracket on it. So I'm going to do 3 squared plus bracket minus 1, close the bracket, squared. That's exactly what I wrote over here. Press equals and I get 10. So h squared equals 10. To calculate my value, I'll do square root of 10, square root of the answer, and that's 3.16. Now I'm going to ask, we'll do one decimal place again. So 3.1, the 6 says round up to 2. Some of you may actually get the calculator actually saying square root 10. On Casio calculators there's a button here that says SD, and that allows you to change it between what's called surd and decimal form. That's what the two mean. Surd is an exact way of writing the number, because this number goes on forever. The square root of 10 is a bit like pi, it continues forever. Strangely enough, the two are quite close to each other as well. So that's one example. Let's do another example going across corners. So let's go from there to there, and I want to know that line. So we're going from -1, -3 to 2, 2. If you're going to do it in a couple of ways, we could do the AB. A is my vertical distance, what's the difference between 2 and -3. And B is my horizontal distance, 2 and subtract -1. What's the distance between them? How long are they? And that actually says this is 7 and this is 3. That's a thinking step, or you could draw it on here. Now I'm going to use red for this diagram, so I'm not going to confuse my triangles too much. So in there, distance here is 2, 4, 5. Oh, sorry, yeah, that's why I made a mistake with that number. 2 subtract -3 is 5. Yes, I do make mistakes. You should be used to that by now. And so the height here is 5, distance across was 3. So you can do it by actually calculating the lengths yourself, doing it by a forced calculation, but remember we want the length here. Just for completeness, I'm going to do CD and remind you that if I see two lines around a pair of letters, it's saying how long is that line. How long is the line? Okay, little note for you on it. So to get CD, we've got CD squared is my hypotenuse. It is the other two sides. A is 5 squared, or A5, plus B squared. Put those numbers into the calculator and get your answer out. So 5 squared plus 3 squared. Again, these are steps I would like to see in your calculator or in your screen. I don't mind not seeing the next step that you're going to do the square root, but we say the length CD is the square root of 34. So if I do square root of my answer, it tells me 5.83. The 3 rounds down, so it's 5.8 units. Whatever the units were. I'm just going to check that using Geogebra, if I can bring it back in. Let's rescale that. First point was at -4,3, so we're doing the first one. Second point was -2,1. -1,2, sorry. There's my points, and if you look on the graph, it tells you the length of that line is 3.16. We rounded it up to 3.2. Second one is minus 1, minus 3. And 2, 2. There's my 2 points. That's what I called CD on here. It says 5.83. We rounded it down to 5.8. Yeah, I will do this as part of one that I'll show you. No, I'll leave that for the moment. I'll talk about the others at another time. So that's how you can calculate the length of line between 2 points. I'm going to put up an exercise. Show the stuff that's in green in your calculations. If you need to draw a set of axes, do. If you're not drawing a set of axes, you might want to say how long are the differences in x and y. And that's an important step, is knowing that this is the change. Remember, the triangle means change, and because I did that as y and b in change in x. They're back from when we were doing algebra and equations of lines. If you remember, the gradient of a line is the change in y divided by the change in x, or 5 over 3. Okay, so this is quite closely linked. You often find questions are linked to these.